Okay, now for some exercises of our pattern sequence and series for grade 12. We're going to do a few from previous question papers. So let's start with this question here. It says the following geometric sequence is given. So the geometric sequence that is given is a 10, 5, 2.5, and 1.25. All right. So the question says it's a geometric sequence. So on 2.1, that says we have to calculate the value of the fifth term in terms of T5. All right. So let's have a look. We know that the formula for the geometric sequence for Tn, because they said we have to give it in terms of, let me just go back there, in terms of T5, the fifth term. So the formula for the geometric sequence is Tn equals to A r to the power of n minus 1. Our A is the first term, which is 10. To find the r, it has to be r equals to term 1, which is 5, divided by term 2, which is 10. This is equals to 1 over 2. You can even conform it by doing term 3 divided by term 2. So that will be 2.5 divided by 5, and then it gives us also 1 over 2. So the constant ratios are equal. So our constant ratio is a half. All right. And then now for substitution, they wanted the fifth term, that is T5. That means our n is 5. We substitute, our A is 10 into our constant ratio is a half to the power of 5 minus a 1 equals to, so I'm just going to put this into a calculator to get the answer. And the answer is 0.625. 0.625. In two decimals, we can say it's 0.63. All right. The next question says, determine the nth term Tn in terms of n. We want the nth term Tn in terms of n. All right. So what will be our term then? Tn, the general term Tn will then be equal to, if you write the general term, you always replace your A and R, just A and R, leaving n not substituted because it said in terms of n. So our A is 10, our R is half, and then we say to the power of n minus 1. That is the correct format. Do not be tempted to multiply the base of that exponent there by 10, making it 5 to the power of n minus 1. Remember, an exponent, its base cannot be multiplied by a number. Even when you have two exponents with two same bases, you would then add their exponents. But if the bases are different, then you leave them alone with multiplication as well as a division. And then if it was a addition and subtraction, then you would have taken out a common factor. So these are the basics from grade 10 and 11. So just remember not to make that mistake. So you will leave it in this form. Explain why the infinite series converges. Let's see. Our R, we found it to be a half. And then this in decimal form is equals to 0.5. This 0.5 happens to be between -1 and 1. So that makes that series convergent. Okay. It converges because R is between -1 and 1. It's that simple. Remember, if it's not within this interval, then it's divergent. If we had found it to be greater than 1 and then less than -1, then we were going to say it's divergent, it's not converging. The next question, so the answer is that simple. You show them that R is 0.5, which is between -1 and 1, therefore it converges. So now we want to determine S infinity minus Sn in the form of ABN, a times b to the power of n, where Sn is the sum of the first n terms of the sequence. Let's see. We want S infinity minus Sn. The formula for S infinity, it was a over 1 minus r, and that of Sn is a into 1 minus r to the power of n all over 1 minus r. Okay, let's substitute. Our a is 10. We have 10 over 1 minus a half, which is our constant ratio, minus a is 10 again, into 1 minus a half to the power of n. This is in terms of n. We don't know what n is. It's not given in that question. And then 1 minus a half. Okay, let's try to simplify this further. We are going to have 1 minus a half is a half. 10 divided by half is 20. Minus, we have 1 minus a half again, which is a half. 10 divided by that half is going to be 20 into 1 minus half to the power of n. So we have 20 minus 20 times 1 is 20. Negative 20 times half to the power of n is going to be plus 20 times half to the power of n. Remember, this is an exponent. We're not going to multiply that base half with the 20. 20 minus 20 is 0. Then we are left with 20 times half to the power of n. Let's just put the half in a bracket. And then it is in the form that they wanted, a times b to the power of n. So for question 3, consider the series Sn minus 3 plus 5 plus a 13. Okay, let me just write it down. We have Sn equals to minus 3 plus 5 plus 13 plus 21 plus dot dot dot. 2n terms. The first question, determine the general term of the series in terms of tk. All right. So since it's in terms of tk, that would be, we're looking for the sequence. So let's check if we're getting a constant difference or a ratio. Okay, T2 minus T1. That would be 5 minus a 3. It's going to be 5 plus 3, which is equals to 8. And then now the term 3 minus term 2, that is going to be 13 minus 5 is 8. And 21 minus a 13 will also be equals to 8. So that means we have a constant difference. Our D is equals to 2. The general formula is Tn of an arithmetic is equals to Tn. Remember that we did the geometric on question 2. So of the arithmetic is Tn equals to A, the normal one you learned from grade 10, plus n minus 1 into d. All right. So let's see if we were given an n. We want it, or in terms of tk. So that means our n is a k. So we're going to say tk. We're substituting n for k. Our first term is minus 3 plus our n is a k minus 1. Our constant difference is 8. Okay, we're going to have minus 3 plus k times 8 will be 8k, and k times minus 1 will be minus 8. Then we have, let me just see the form they wanted in, bk plus c. So that means we're going to have 8k minus 3 minus 8 will be minus 11. Tk is equals to minus 8k minus 11 in that form. And then the next question is that we should represent this in a sigma notation. Remember the sigma notation? It's that sign there. Okay, we need to represent 8k in minus 11 in a sigma notation. So since the variable is k in this case, our k has to start from somewhere. Up to, we were told that this term is up to the nth term. So this would be up to n. Where should we start? We need to find the number such that if we substitute it, it will give us minus 3, the first term. So let's try 1. If we say k is equals to 1, 8 times 1 will be equals to 8. 8 minus 11 is minus 3. So k has to start from 1. So that is the sigma notation. And you can also substitute a 2 to see if you'll get a 5. So that will be 8 times 2, that's 16. 16 minus 11 will give you a 5. So K should start from 1. All right. The next question, we need to show that Sn is equals to 4n squared minus 7n. All right. The sum, let's go get the sum of an arithmetic sequence Sn. The formula is n over 2 into 2a plus n minus 1 times d. Okay, substitution, n over 2 into 2 times the first term is minus 3 n minus 1, and the constant difference is 8. Okay, we will come and end with this n over 2. 2 times minus 3 is minus 6, plus n times 8 is 8n, minus 1 times 8 is minus 8. So we're going to have n over 2 into 8n minus 6 minus 8 is minus 14. All right, so our Sn is equals to, so let's multiply this to 8 divided by 2 will be a 4. Okay, then 4n times this n will be 4n squared, basic algebra. And then the second one, 14 divided by 2 is going to be 7, and then 7 times n will be 7n. And we've proved what they needed. So the next one says another sequence is defined. Q1, so this is a sequence. When they say Q1, that's the first term. That means the first term is minus 6. The second term, let me just try to write them down. All right. So the first term was minus 6. The second term is minus 6 minus 3, which is minus 9. The third term is minus 6 minus 3 plus a 5. This is going to be equals to minus 4. The fourth term is plus a 13. That will be 9. The next term is plus 21. This is equals to 30. All right. Okay, let's get the first question of that. The first question is that we should write down Q6. Q5 was minus 6. Minus 6 minus 3 plus 5 plus 13 plus 21. What are they adding to get to the next term? So they all, let me go, start Q6 will be equals to, they all start with minus 6. So we're going to have minus 6 minus 3. There was plus 5 plus 13 plus 21 plus 13 plus 21. What's going to be the next number after 21? Let's check. All right. From minus 3 to get to a 5, you should have added an 8. Okay. If you say minus 3, so it's the constant difference of that 8 that we found at the beginning. Minus 3 plus 8 will give you a 5, and that 5 plus 8 will give you that 13, and 13 plus 8 will give you that 21. So now we need 21 plus 8, so that means the next one is going to be 29. So your Q6 will be minus 6 minus 3 plus 5 plus 13 plus 21 plus 29. So that is the numerical expression, the way they've been giving it. So now we need to calculate the value of Q129. Q129. Please do notice that these terms here, these terms here, minus 3 plus 5 plus 13 plus 21, they look the same as that original Sn that was given. Okay. So this Q, let me just minimize this. This Q, this looks the same as the original term that was given, which we found the general formula of to be this. All right. So it's this without the minus 6. So that means that Q129, 129, we can simply say this is minus 6 plus Q128. Because if we remove this minus 6, which is always there, then we are only left with 128 terms instead of 129, because now we have an extra minus 6. So we have minus 6 plus, so this, since this term is the same as this one, which we calculated general term to be this, so that means we're going to have 4, n is 128, squared minus 7, our n is 128. And all of this into a calculator will say the answer is 64634. Alternatively, remember we had that sequence there that we created from the Q1, Q2, Q3. So we could try to find the constant differences. So we have minus 9 plus, it's going to be minus 9 minus minus 6, which is minus 9 plus 6. And this will be minus 3. And then minus 4 plus a 9 will be 5. That will be 5. And this one is going to be 9 plus 4. That is equals to 13. And lastly, we will have 30 minus 9, which is equals to 21. So there is no constant difference. Obviously, if you take term 2 divided by term 1, it won't be equal to term 3 divided by term 2. So it's not ratios. So let's see if we have a second constant difference. Yes, there is. Just notice that minus 3, 5, 13, 21 is equals to that thing that we originally had, which had a constant difference of 8. So we have a constant second difference. So we can say 2a is equals to 8. This is grade 11's work. Equals to this 8. Therefore, a is equals to 4 if we divide both sides by 2. And the next one is 3a plus b is equals to the first difference, which is minus 3. So we have 3. Our a is 4 plus b equals to minus 3. So b will be equals to minus 3 minus 12, which is minus 15. And lastly, a plus b plus c equals to our first term there, which is equals to minus 6. So a is 4, b is minus 15, and we are looking for c. Therefore, c is equals to minus 6 minus 4 plus 15. We have minus 6 minus 4 plus 15, and that will be equals to 6. Therefore, the general term is a quadratic sequence, which is equals to a. So the general term formula is a n squared plus bn. We know this from grade 11 plus c. So that means we have our a is 4. This is 4 n squared plus b is 15 minus 15n plus 6. And then what was needed was Q 129 will then be equals to 4. N is 129 squared minus 15 times n, which is 129 plus 6. So putting this into a calculator will be equals to the same answer, 6, 4, 3, 6, 3, 5. 6, 3, 5. So this is a bit longer, whereas the first method was a bit shorter. But